Alright guys and girls, Coach Q back once again, and this time I'm doubly irked because I've done it 2 days in a row where I've literally done the whole video and forgot to press screen record. Oh my goodness! Alright, so anyways, we're back with another fun-filled, action-packed, non-flipped Algebra 2 classroom video. So far guys, we've learned to evaluate the functions, such as when we're given a function like f of x equals 2x squared plus 11. We can evaluate it when it's like f of 3. Then we learn to add, subtract, multiply, and divide functions, okay? And now we're going to do something that looks similar, definitely not reading off the script, but it is not the same. Can you figure out how we got to these answers? Check this out. Look at A right here. Given that f of x equals x, I should use the blue one first because we've been doing that. F of x equals square root of x, and g of x equals x plus 5, f of g of x equals square root of x plus 5. How the heck did I get that? That makes no sense. Well, check this out. Let's take a look at what this actually says. Let's start from the inside and then read outside. The inside of this says g of x. What is g of x, guys? G of x, we can see right here, is x plus 5. So then now let's change this to have it read like this. F of x plus 5. Alright, now we can see that f of x over here is square root of x. But this time we're replacing the x with the x plus 5 that is actually g of x. So if we replaced it, it would be like this. Square root of x plus 5. Whoa! Let's look at the next one. F of x equals x squared, and g of x equals x minus 3. So, once again, f of g of x equals x squared minus 6x plus 9. How did I get that? Once again, let's start from the inside. Look, what's on the inside? It's g of x. And what is g of x? It's x minus 3, so x minus 3. And then we've got the f function on the outside, so it's going to be f of x minus 3. Well, f of x is originally x squared, so this time it's going to be like this. It would be x minus 3 squared, which is the same thing as x minus 3 times x minus 3. So then we're going to distribute. We're going to go x times x. That is x squared. Then we've got negative 3 times x. Then we've got x times 3, x times negative 3. Whoa, x times negative 3, which is negative 3x. All right, let's go to the next term. We've got negative 3 times x, which is negative 3x again. And then lastly, we've got negative 3 times negative 3, which is positive 9, so plus 9. And so if we combine our like terms, we would see that this is the same as x squared minus 6x plus 9, which is what this section over, oh shoot, which is what this right here is. We got the exact same thing. So these functions are known as composite functions. Say it with me, composite functions. Composite functions. Composite functions. Or they're called compositions. So composite functions or compositions. Composite functions are functions that are, oh, there was the R, whoops, that are inside of each other. So let's take a look at an example then. So you see A down here, 1A right here. It says f of g of 3. First, we're going to start on the inside. Remember, g of 3. Well, the g function is right here. So look, instead of writing g of x, I'm going to write g of 3, which I'm going to replace the x. It's going to be 3 squared. What is 3 squared, y'all, that is going to be 9. So it's going to equal 9. That means g of 3 is 9. So now I've dealt with the inside. So the next step is going to be f of 9. So then f of x is right here, 2x minus 5. So instead of the x, I'm going to write 9. So it's going to be 2 times 9 minus 5. What is 2 times 9? That's going to be 18. And then we bring down the minus 5. What is 18 minus 5? 18 minus 5 is 13. I almost said 3. And so this is the answer of f of g of 3. Let's look at b. b is going g of f of 3. So let's look on the inside. This time the inside is f of 3. So let's write the f function. F of 3 is going to be 2 times 3 minus 5. We replace this x right here with a 3. All right, what is 2 times 3, guys? That's going to be 6 minus 5. What is 6 minus 5? 6 minus 5 is 1. All right, so now I found, get out of here. Now I have found f of 3, so I can use this number inside the g function right here. Because I know f of 3 is 1, I can just take this out and put 1. So now we're looking at g of 1, so g of 1 is going to be the same thing as 1 squared. And 1 squared is 1. So this evaluated function right here, g of f of 3, is actually equal to 1. All right, let's scroll all the way down to 4 and do a couple more complicated problems using just x. All right, so look at A. It says g of f of x. Let's color code this real quick. F of x is up here, and g of x is right here. So looking from the inside, it's always inside first. F of x. What does f of x equal? It's x squared plus 1. So I'm just going to go ahead and write that. Now x squared plus 1. And on the outside, we still have that g parentheses. Okay, we can see the g function is going to equal, g of x is 3x minus 5. So if I replace the x with x squared plus 1, I would end up writing something like this, equals 3 parentheses, let me use color code, x squared plus 1 minus 5. And so now from here, we're just going to distribute and work it out. So 3 times x squared, 3 times 1. What is 3 times x squared? That's going to be 3x squared. And what is 3 times the 1? That's just 3, so plus 3. And then we bring down the minus 5. Now we just need to combine like terms. Do we see any x squareds besides this 3x squared? No, so we're just going to bring this down, 3x squared. And then let's combine our numbers. We've got positive 3 and negative 5. What is 3 minus 5? That is minus 2. And that is my answer. So g of f of x here is equal to 3x squared minus 2. Now we're going the other way, f of g of x. So look at the inside first. That's going to be g of x. What is g of x? So we can see right here, g of x equals 3, still on the highlighter, 3x minus 5. 3x minus 5. So we can replace this g of x with the 3x minus 5. And so now I'm just going to write f of 3x minus 5. So we can see the f function originally, if we replaced it with 3x minus 5 and all the x spots, it would be like 3x minus 5 squared plus 1, like this. And so what does this all really mean? 3x minus 5 squared is the same as this. Let me draw an arrow. It's going to be over here. 3x minus 5 squared is the same as 3x minus 5 times 3x minus 5. And then we can't forget the plus 1 on the very end. So let's go ahead and distribute this. First, let's go 3x times 3x. What is 3x times 3x? That would be 9x squared. Next, we got to do this 3x times the negative 5 back there. 3x times negative 5 is negative 15x. All right, we've taken care of that now, so let's go to the negative 5. This negative 5, we need to multiply it by 3x. What's negative 5 times 3x? Once again, that is minus 15x. And then lastly, we're going to go this negative 5 times negative 5. What is negative 5 times negative 5? That is going to be positive 25. So let's combine our like terms. The only x squared is over here, so I'm just going to bring that down. 9x squared. All right, the x's are right here, negative 15x, negative 15x. So negative 15x minus 15x is going to be minus 30x. And then lastly, we can see the only number here is plus 25, so we just bring that straight down. Plus 25. So actually, it's going to be plus 26, because we got the 25 and the 1 right here. 25 plus 1 is 26. So this is my final answer, 9x squared minus 30x plus 26. Now look at this. Look at these two answers. One of these questions asks for g of f of x, and the other one asks for f of g of x. So if we look up here, do f of g of x and g of f of x always have the same answer? No, they do not. We just did an example where these two expressions were different answers. Okay, going down here. So just like function operations have different ways you can write it, so do composite functions. So look at this fancy terminology. G of open circle. So look at this fancy terminology. G open circle f of x. That really means g of f of x. And then we've got the f open circle g of x. This one means f of g of x. So it really stays in the same order of whatever's before the open circle and whatever's after the open circle. Now be careful though, because look at this. G, oh man, this looks so bad when I try to write it. G of f of x is not the same thing as f times g of x. This open circle and this multiplication dot are not the same thing. Alright, so our last examples, we're going to prove that we're going to show you the difference between the composite function and the multiplying function. So look at number 5. This first one, what does this mean right here? This is the same thing as saying f of g of x. So let's work our way from the inside to the outside. Let's color code it too. Boom, that's that. And then f of x is this. So g of x, what is g of x, guys? It is x squared minus 1. So we can rewrite this as f of x squared minus 1. Okay, so now instead of writing the x right here, I would write x squared minus 1. So this is going to end up being it's going to end up being 5 times x squared minus 1 plus 2. So let's distribute. What's 5 times x squared? That's going to be 5x squared. What is 5 times negative 1? That's negative 5. And then we cannot forget the plus 2 at the very end. And so let's combine the like terms. The only x squared term is the 5x squared. So we're going to leave that like it is. So 5x squared. And then the solid numbers that we have are negative 5. Are negative 5 and positive 2. So what's negative 5 plus 2, that is going to be minus 3. So right here, f of g of x is going to equal 5x squared minus 3. Looking at b, showing you that the composite dot and the multiplication dot are different. This b says g times f of x. This is the same thing as saying, oh wait, let's color code it again. And one of these. This is the same thing as saying g of x times f of x. What is g of x? That's going to be x squared minus 1. And f of x is 5x plus 2. So we did this yesterday, but let's distribute. X squared times 5x equals 5x cubed. And then next, let's take this x squared and multiply it by 2. What's x squared times 2? That's going to be plus 2x squared. All right, so next, let's go to this negative 1. Negative 1 times 5x is minus 5x. And then lastly, negative 1 times positive 2 is minus 2. So as you can see, there are no like terms here to combine. So this is our final answer, 5x cubed plus 2x squared minus 5x minus 2. That is the product of these two functions. And with that, guys, that's going to end these notes on composite functions. So see you in the next one. Peace!